Hi everyone, I am Namita from CSEB. Today we are going to discuss about the CPU scheduling. So the contents we are going to discuss are given below as introduction to CPU scheduling and process involved in it, CPU scheduling criteria, types of scheduling, preemptive and non-preemptive and various CPU scheduling algorithms. So let's see one by one. So first introduction to CPU scheduling. So what is CPU scheduling? It is nothing but the process of selecting a process from the ready queue for execution. The CPU continuously assigns multiple jobs for executing so that it will not go for the idle state. So making the CPU continuously assigning jobs, it makes the CPU busy and increase the efficiency. So in multi-programming system, CPU should be always make busy to maximize the efficiency. So CPU scheduler decides which process get the CPU to minimize the delays. So scheduler will assign multiple jobs according to the priorities and etc. So next process of CPU scheduling. So in this we have many process, that is first of all arrival of process. So when a process is created, a new job is there which moves to the ready state for execution of the process. So after moving to ready state, the CPU scheduler selects a process from ready queue based on scheduling algorithm. So algorithms etc. are HCFS, SJF and RR. That is first come first serve, shortest job first and round robin. So in execution, the selected process gets the CPU and starts running. So there are interrupts and preemption. If a higher priority process arrives, the current process may be passed and moved back to the ready queue. Completion or input output wait. If the process complete, it terminate. If it needs input or output, it moves to the waiting state. Context switching. If the CPU switches to another process, it saves the current process state and loads the next one. So if the CPU have the highest priority process to be executed, the process which is already there, it move to the waiting state and then it moves against to the ready state and execute the process. So this is the way of executing the CPU scheduling process. So next we have various CPU scheduling criteria: CPU utilization, throughput, turnaround time, waiting time and response time. So CPU utilization nothing but the percentage of time the CPU is actively processing the task. The CPU is continuously performing the task means the utilization of CPU is very high and efficiency is also very high. So in throughput it's defined as number of process completed per unit time. That is, the number of process completed is higher, the throughput is also higher. So in a particular time the CPU execute n number of tasks so that it increases the throughput and efficiency. In turnaround time it's like a time difference between the completion time and arrival time of the task. So the waiting time is nothing but time difference between turnaround time and burst time. So the response time is time between request and the first response from the system. So it's not the completion of the task, it is the response the system is providing at first for the particular task. So basic of CPU scheduling criteria. So we have some tasks to be maximized and some to be minimized. In the CPU scheduling criteria, the utilization and throughput should be maximized to increase the efficiency and output. The turnaround time, waiting time, and response time are to be minimized to increase the efficiency and scheduling of CPU. So the types of CPU scheduling. So preemptive and non-preemptive are the major types. So under the preemptive we have four categories: priority scheduling, shortest remaining job first, longest remaining job first, round robin. So in non-preemptive also we have four categories: first come first serve, shortest job first, longest job first, highest response ratio next. So let's see one by one about each criteria. So the major difference between preemptive and non-preemptive scheduling. So in preemptive, the OS can interrupt the running process and switch to another. If the process is already running in the OS, the arrival of another process may interrupt the already running process in the system. But in case of non-preemptive scheduling, the process once start will complete the execution. After that only it runs the another process, so that there is no interruption occurs in this scheduling. So for example, in preemptive, round robin, shortest remaining job first, longest remaining job first, and priority scheduling. And example for non-preemptive schedulings are first come first serve, shortest job first, longest job first, highest response ratio next. So let's see what are the steps to find this scheduling. So these are the various scheduling algorithms, and let's see the brief description of each level. So first come first serve. So in this condition, the process which comes first is executed first. So when arrival time is greater than or equal to time at present, so the process is executed at that time. So this process is easy to perform and it follows the first in first out queue approach. So the disadvantage is it is not efficient because of convoy effect. Convoy effect is nothing but slow process cause entire system to slow down. So based on first come first serve you are taking that it will become more slow. So this causes the entire system to slow down the process. So let's see the problem. We have 5 process given and arrival times burst times are given in the table. So we have to represent the Gantt chart for the processes. So we are representing the 5 process in the Gantt chart, and initially the arrival time is 0 and the waiting time is 0 at initial. Next for P2 we are having the first come first serve order 10 is at first position, so that we are getting 10. Next we have 5 at that position, so we are adding 5 to the 10, 15. And next we have 2 at that position, adding 2 to the 15 we get 17. And we are adding 6, we get 23. After that finally at P5 we are having 4, so we get 27. So all the waiting times are given to the each process. So average waiting time has to be calculated by using uh, waiting time of P1, P2, P3, P4, P5 are added and they are taken average. By total number of process is taken to be division process. So but totally we have 65 waiting time. So divided by 5 equal to 13 is the average waiting time. So next we have shortest job first. It selects the process with smallest bird time first. It switches to new shorter process if it arrives. So pros or minimizes the average waiting time and high efficiency for batch processing. Cons require knowing process burst time in advance. It also causes starvation, that's the long process may never get executed. It will give only priority for the shortest job, then the longest jobs are waiting in the queue continuously without executing, so it causes the starvation for longest process. So for example, we are having 4 process and burst times are given. We have to give priority for the shortest time. So for at first we are taking P4. It has a time 2, it's very minimum. And next we are taking P2 and 3 is the minimum value. So adding 2 plus 3 gives 5. Next we are taking P3 which has a minimum value 6. Adding 5 and 6 provide 11. Next we are taking the P1 which has the highest value 21. Next to another shortest value. So by adding 11 plus 21 it gives 32. So to find the average waiting time we have to add 0 plus 2 plus 5 plus 11 divided by total process that is equal to 4. So the answer will be 4.5 milliseconds. Next we are going to see round robin. So it is a preemptive type. Its working principle is each process gets a fixed time, that is quantum time is given before switching to the next process. So for every process they are considering the quantum time to be taken for the evaluation of waiting time. So pros is it ensures fairness. Each process gets the CPU time. It's good for time sharing system. And cons is too small quantum increases more context switching and large quantum acts like first come first serve. So example is we have 4 process given and arrival time, burst time, priority, completion time, turnaround, waiting, response, all the times are given. So while drawing the Gantt chart, we are taking The value quantum value is given as 2. By taking that we are solving the each step, we get the answer average waiting time as 2.5 and turnaround time as 5.5. Next, priority scheduling. It's a preemptive type of scheduling. Each process is assigned a priority value and the CPU executes the highest priority at first. So, it prompts is allows critical process to execute first. It is flexible and can be customized based on system needs. Cons. Starvation. Low process priority may never execute, as it's giving more priority to the highest value. Lowest value are not given any priority, so it may causes the starvation. Solution. Aging. It gradually increases priority of waiting processes. Here we have 5 processes and priorities are given and burst times are given. Based on the priority, we are taking P2 at first, which is having the value burst time 1. And then we are taking the value P5, which having the priority 2 and have the burst time 5. So we are adding 1 plus 5, it gives 6. Next we are taking P1, which has the priority 3 and burst time 10. Then 6 plus 10 provides 16. Next we are taking the P3, which has the fourth priority value 2. 16 plus 2 gives 18. Next we are taking P4, which has the fifth priority and value 1. So 18 plus 1, 19. To find the average waiting time, we have to add all these values and divided by the total number of processes. So it provides 8.2 as the answer. Then multi-level queue scheduling. Processes are divided into different queues based on priority. Each queue has its own scheduling algorithm. Pros. For example, foreground uses round-robin technique and background uses the FCS technique. So prompt is it separates the different types of process and efficient for system with different workload types. Cons. Rigid process cannot move between queues. Can lead to starvation for low priority queues. So here the various scheduling algorithms are compared with their type, best use case and key issues. So first come first serve is a non-preemptive type and it uses the batch system and it has the effect of convoy problem. SJF, shortest job first, is both preemptive and non-preemptive. It gives the priority for shortest process and the key issue is starvation. Round robin is a preemptive type of scheduling and the time sharing is high. High overhead means the quantum is very small. Priority, it's both preemptive and non-preemptive. It has critical process at best use case and it can lead to starvation. Multi-level queuing. It is preemptive type of scheduling and different user can use this type of scheduling. So no process movement arises in this technique. So these are compared in order to give the clear idea about the CPU scheduling algorithms. So thank you for listening my lecture. We will meet in the next topic.